In this video, we're going to be reviewing the types of chemical bonds, with our focus being on intramolecular forces. So here we have intramolecular forces. And what intra essentially means is that these are forces that hold the atoms together within a compound or within a molecule. We're not going to go into the intermolecular forces, but I'll show you the difference quickly. So here we have water, like this. I'm just drawing a quick structure here. This bond here, this covalent bond, this is an intramolecular force. It holds the atom of O and H together within the H2O compound. Now, water molecules, they can interact with each other. And this is not drawn properly, but essentially the O of one water can be attracted to the H of another water. And this would be an intermolecular force, which is a force that doesn't hold the atoms together within a compound, but it holds different molecules together between each other. And so that would be an intermolecular force, which we'll review later on. But right now our focus is on the stuff that holds the atoms together within a compound. So the main types of chemical bonds or forces that hold the atoms together within a compound can be seen here. They're the Ionic bonds, the covalent bonds that are non-polar, the covalent bonds that are polar, and the metallic bonds. And so as a brief overview, you might remember that you might have ionic bonds, which typically form between a metal and a non-metal. And so a great example of that is the bond between sodium and chlorine in sodium chloride. Basically, your sodium loses an electron to the chlorine, and you get a charged sodium ion and a charged chloride ion with opposite charges, and they're attracted to each other because they have opposite charges. This is the ionic bond, and it's the result of electron transfer. In some cases, you won't have an electron transfer. Instead, you'll have electron sharing. So that usually happens between two or more nonmetals, and that's called a covalent bond. So this is sharing instead. There's two different types of sharing that you can see. You can see equal sharing of electrons, and you can see unequal sharing of electrons. The equal sharing is generally called non-polar, and the unequal sharing is called polar covalent. So an example of equal sharing would be in the H2 molecule, where the H's are sharing electrons equally, whereas unequal sharing, polar, would be in the H2O molecule, where the electrons are spending a little bit more time towards the oxygen end as opposed to towards the hydrogen end. And that's because oxygen is more electronegative compared to the hydrogen, which is more electropositive. So hopefully a lot of these terms are coming back and it's starting to make some more sense to you. So we just reviewed the ionic bonds, which are formed between a metal and non-metal through the transfer of electrons. And we saw the covalent bond, which is a share of electrons instead of a transfer. And that happens between two or more nonmetals. And if you have equal sharing, it's nonpolar. Unequal sharing, it's polar. And we saw two examples there. The last type of bond that you might see, which is considered intramolecular, is called the metallic bond. And the metallic bond essentially happens between metal atoms. And they can be metal atoms of pure metals or alloys. And an alloy is simply a mixture of metals. So if I have a brick of gold or a bar of gold, all the gold atoms within that bar of gold are held together by metallic bonds. And what that is essentially just a C, we say it's a C of metal, or we say rather, it's metal cations in a sea of electrons. And these electrons are said to be delocalized. And what that basically means, if you look at this image here, is that you have all these metal atoms here, and they're not very electronegative. So they don't really hold their electrons down to one specific nucleus. Instead, the electrons become delocalized and can swim around from atom to atom to atom to atom. So that's why we say it's like you have these positive ions, these positive cations of metals swimming around in the sea of their electrons, which are delocalized. They're not tied down to one specific nucleus. Rather, they're hopping around from nucleus to nucleus to nucleus, or from atom to atom to atom within the entire sample of metal. And so all these different bonds are responsible for giving the properties to the different substances that you know. In the next video, we're going to focus on looking at bond polarity. Most of our focus will be on the ionic and covalent bonds to tell the difference between them. And after we've become experts at identifying bond types, we're going to try to classify molecules as being either polar or nonpolar.